So I wanted to go over an overview of Layer 2 networking. The very basics are, this is just traffic going from one switch to another, or one switch to a router but not actually doing any routing. And one of the main things to note is if you are in one subnet and you try to go to another, that will not work. Subnets are a generally layer 3 thing, so all this does is MAC addresses. So the MAC address is the hardware address that your computer or NIC will have. Each MAC address is derived from the hardware that it's given, so there's no overall arching strategy as to where this MAC address will be. It is a 12-digit hexadecimal number. It has no way that it's always written, so it might be a dot every 4 characters or a colon every 2 characters or anything else. Pretty much anything is open for how you want to write it, but those are two of the most normal ways. So inside the switch, it keeps track of which MAC addresses are associated with which ports. So it just watches a port, looks at the source MAC address of each packet, and learns what MAC address is on that port. Using this, the switch will send packets out only where they should go. So this is how the switch learns the MAC addresses. So a packet comes into the switch with a source MAC address of A, and now the switch knows that any packet with a destination MAC address of A should go out gigs 01. So there is the broadcast MAC address that is all Fs. Basically what this does is it tells the switch to send this packet out every port that the packet did not come in on. Also, a switch that doesn't know where the destination MAC is, for a packet that comes in, it will broadcast that packet out. So what precisely does this look like? So the packet comes in this case it's a broadcast packet, but it might be a packet that the switch does not know where that destination packet is. So it comes in on one interface, then the switch sends it out on every interface that it did not come in on. So let's talk about spanning tree, or STP. This is an old protocol. It's sending out Bpdus. I always thought of these as a boomerang packet. These Bpdus go out of every port that it has, and it starts listening on all of its ports for those Bpdus to come back to it. If those ports come back to it on a different port than they were sent out, then there is a second path through the network, and that is bad. That would lead to a layer 2 loop by default. So the goal of spanning tree is to make it so there's only one path through the network from one point to any other point. And it does that by basically blocking all traffic on particular ports, just to set it up so there's only one path. There's lots of different types of spanning tree that have minor differences. If you want to influence what the path will look like, you can use priorities, port costs, etc. to figure that out, but that's beyond the scope of this video. So what exactly does this look like? So if you have this topology here on the left, currently you can have a lot of layer 2 loops if it wasn't for spanning trees. So you can get a loop here, etc. You can see how if one packet came into the switch and it got broadcast out on all the other ports, and it got broadcast out on all the ports, and repeat that for every switch, you could have quite a mess. So what spanning tree does is it goes through, figures out, hey, I don't need this link, this link, this link, or this link. I'm just going to block those. And you end up with a usable set of ports that looks like this here on the right. That is spanning tree's goal, is to hack out all of the extra ports that you don't need. And yes, that means that bandwidth is no longer available. So I wanted to go over Bpdu guard versus Bpdu filter on the interfaces. These are two protocols that sound very similar, but they do very different things and could cause significant issues. So Bpdu filter on an interface just ignores the Bpdus that come in on the interface, basically disabling spanning tree. Bpdu guard, if it sees a Bpdu come in on that port, the port will just error disable, and that port will be down until an admin comes in and manually fixes it. You put this out on a switch, on a port that you don't want a switch plugged into. Very different, and I've seen this mess up a lot of things. So I wanted to go over that in particular. So let's talk about port types. There are two real different kinds of ports. There's the trunk port and the access port. The access port is the general use port. It has one VLAN on it. Every bit of traffic that comes in on that port is thought to be on that VLAN. So the trunk port is a bit different. When I said earlier that one VLAN can only go through and talk to other ports on that VLAN, there is a exception to that, and that's the trunk port. What the trunk port is a special port that pumps traffic from multiple VLANs down that port and tags each of those packets with what VLAN it's on. It does that tagging with the 802.1q tag. And every data packet that comes through there is tagged with the VLAN number, other than the native VLAN, which is untagged. So let's see an example of how that works. So up here, you have a normal packet coming into VLAN 1. The normal packet goes into the switch and comes back out completely unchanged into a VLAN 1 and out of a VLAN 1 port. But this second packet comes into the VLAN 1 port, into the switch, and then out of the switch, it comes as a tagged with .1q, saying this is a packet from VLAN 1. So let's see how that trunk port works the other direction. So on the left, we have a packet from VLAN 2. It goes into the switch, and then back out the VLAN 2 port is a normal packet without the headers. And now in the bottom left, we have a normal packet coming in on VLAN 3, and the trunk port's native VLAN is VLAN 3. So the packet goes up to the switch and comes back out on layer 3, as VLAN 3 on the trunk port, completely untagged. Once again, this is because VLAN 3 is the native VLAN, so you need to make sure that your native VLANs match up, because if you have native VLAN 3 on one port, on one switch, connected to another switch where the native VLAN is 1, then your VLANs won't match up, and you will have a VLAN hopping issue. I hope this has been helpful. Thank you. Bye.